Hello everyone, it's Mrs. Lawson. We are in week 6 and we are going to be leaving our solving section and start focusing on the parts of a parabola or a quadratic function, and also next week in week 7 how you will graph them. So today is more about the vocabulary that we need for you to understand when it comes time to graphing. All right, so let's go ahead and get started. So the first thing is just, again, the key points of a parabola. So the type of function that we're working with, at the beginning of the year, we introduced the idea of 3 types of functions to you. There was linear, a line. There is exponential, which kind of looks like a capital L backwards. And then there's also the quadratic function, which is going to look like a U. So first part is a quadratic function. You are going to know that you're working with a quadratic function because you're going to see that the function, the equation, the highest degree or exponent is a 2. Okay, so anything where the highest exponent or power degree is 2, that is considered quadratic. The shape of a quadratic, it's not technically called a quadratic. It's known as a parabola. We don't say parabola, it is a parabola, but this is the shape of it. All right. You have what is known as the axis of symmetry. We as people have an axis of symmetry. It's if we just cut a line straight down the middle between our eyes along our nose, it just basically, it's going to cut the shape. So in this case, since we're on a flat two-dimensional surface, it's a plane figure, it's going to cut it into 2 congruent halves, and that they're reflected over this axis of symmetry. All right. We also have a vertex. The vertex is the highest or the lowest point on your parabola. You can consider it the turning point. And just a quick heads up, when we talk about a vertex, we will use an X and Y coordinate. When we talk about the axis of symmetry, I should have mentioned this before, it's basically you're cutting a line, and that line is going to have the equation of X equaling some number, not a hashtag. You also are going to have your X-intercepts and your Y-intercepts. So your graph is the point at which the graph crosses the x-axis gives it the x-intercept name. And the point at which the graph crosses the y-axis is the y-intercept. All x-intercepts are going to be x at some value, and you'll notice that y is always 0. And then when you have a y-intercept, you're going to notice that the x value is always 0, while the y value is at some particular value. We're also going to have what we call the maximum point and the minimum point. So the maximum point, that's the y value of the highest point on the graph. And when we give our answers, we're going to be saying, for instance, the parabola has a maximum value of y equals 3 when x equals 2. That's how we're going to phrase our answer. And if there's a minimum value, then that's the y value of the lowest point on the graph of the function. And again, when we give our answer, it's going to be written out like this. The parabola has a minimum value of y equals 2 when x equals 7. So those are just some examples of how you're going to see this. So let's go through all those key points in this one particular graph. You're going to be doing this in your Go formative practice. So the first thing I want to know is the axis of symmetry. So again, the axis of symmetry just cuts my shape in half so that they are mirror images of each other. So drawing this is my axis of symmetry. And your axis of symmetry is always going to be a vertical line, a line going up and down. And this axis of symmetry, putting over here, since it's a line, it does have an equation, and it's going to be the equation of x equals -2. And the reason why it's x equals -2 is if you start looking at points on this line that I just drew, like this point is -2, 3, or this point is -2, 2, or this point is -2, -2, or this point is -2, -4. And what you're going to see is that on this line, every x value is always -2. So that's what gets to name it. The next thing we're going to talk about is the vertex. So the vertex, again, that's kind of like this turning point mentioned up here. And so, as I look at my graph going left to right, as I start on the left side, my graph is going up. I'll erase this in a little bit. And then it hits this high point, and then that's my turning point, that's my vertex, and then it starts to go back down. So my vertex is a coordinate, and that vertex point is -2, 4. So remember, when you label a point, you always start at the center and you look at how many you went left or right. So I went left 2, and then I went up 4, and that gives me the +4. All right, the next thing are the x-intercepts. So for the x-intercepts, let me switch colors here. I'm looking to see where my parabola, where my function intercepts the x-axis. So it's here and here. And I'm going to write those again as coordinates. So this first point, all the way to the left, is the coordinate of -4, 0, and the one on the right is the point 0, 0. Again, in an x-intercept, all right, the x value will always be a number, and the y value is always, 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 always 0. It's never going to be anything else. Going on to the next one, it's asking for the y-intercept. So the y-intercept is where my graph crosses the y-axis, which happens to be right here, this big X. And if you notice, that also happens to be the x-intercept, and that's okay. Some coordinates can have multiple jobs. So my y-intercept is the point 0, 0. And then the last part is going to be the maximum, and the maximum, and it could, again, there could also be a minimum. It's either a maximum or a minimum. Is where your vertex is, but you're not going to state the vertex. You're going to write it out as a sentence. So we would say the parabola has a maximum value of y equals, and again, this point, just to refresh your memory, is -2, 4. So the parabola has a maximum value of y equals 4 when x equals -2. Do not write the coordinate. The coordinate is the vertex. What we're looking at is the highest point. So a y value gives the highest or the lowest point, and then us stating the x value, this -2, kind of gives it a more defined location. All right, so let's move on. So this next part you're going to see, because we did talk about this somewhere in first semester, I can't remember which chapter, but what are the 3 forms of a quadratic? So you have vertex form, and we've got standard form, and we've got factored form. And you have to be able to recognize, these different forms, because each form is going to tell you something pretty important. So the first thing is, if you start with vertex form, you will know without any math, you don't have to use a calculator or think too hard about it, you're going to see the vertex of your function, of your quadratic or of your parabola. And it's going to be an x and y coordinate, just like we already said before. It's going to be some x value and some y value. And it's really easy to see when you see something in vertex form. What you're going to do is you're going to take the opposite of h. And what I tell my students is h is in the house. And here your house, a house has walls. So your walls are these parentheses. So you're going to take the opposite of the h value, c. That will be your x coordinate. And then you're going to take k, and k is just this number added or subtracted onto the end. And you're not going to do the opposite of k. You're just going to leave k as it is. So when you take k, that'll be your y coordinate. That's not a very good k. All right, the next one is standard form. So if you start comparing standard form to vertex form, you're going to notice that vertex form will always have a set of parentheses with the square. That's what makes it vertex form. But standard form has no parentheses at all. So that's what you're looking for. And again, standard form, that was really important when we were factoring, and especially in the quadratic formula, because standard form allowed you to see what value was a, what value was b, what value was c. Anyway, standard form is really important because just by looking at the equation, you can see the y-intercept. All right, and the y-intercept is always going to be, remember, all y-intercepts have an x value of 0, and it will be whatever c is, whatever this constant number is, the one term that does not have an x attached to it. And I'm going to explain why it's 0 in c when we get to our examples below. And then you've got factored form. So factored form looks a lot like vertex form because there's parentheses, but the big difference is there's no square. There's no little exponent showing up in here. You just see your parentheses, okay? And factored form, you guys already realized by factoring that you found the x-intercepts. You were solving for x. So in factored form, all right, let me start that over. So in our last section, when we were solving, you would have to get things factored if they weren't already in factored form. And your equation would have looked something like this. 0 equals x minus 3 and x plus 2. And then you use the zero product property to find your answers. So you would set each factor equal to 0. Here I'd add 3. And I'd set the other factor equal to 0, and I'd subtract. And you found your solutions. Well, those solutions happen to be, if x is 3, then your y is 0. Or if x is negative 2, then that made the y value 0. And when y is 0, that is an x-intercept. Okay? So real quickly, let me erase this. What you should take away from these notes are that you want to set your parentheses, ooh, don't want the highlighter. You want to set your parentheses equal to 0, and you want to solve. And then whatever that amount is, that number is going to be the x-intercept along with your y-coordinate of 0. All right, so let's look at a few examples. So you're going to have to be able to tell me which form it's in and what's the important point. And again, the important point, we're not going to do a lot of math. The idea is you can just kind of look at it and see your answer. So my first problem, I see parentheses. So it's either going to be factored form or vertex form. But since I don't see a parentheses with a squared, this is factored form. And I'm going to abbreviate and just write factored form. And with that, I can find the x-intercepts. And I can do that by just taking those factors, setting them equal to 0, and solving. So here x is 3, subtract 1, x is negative 1, but our answers we're going to write as x-intercepts. So if x is 3, y is 0, and if x is negative 1, y is 0. Okay? All right, number 2, again, there are parentheses, so that either makes it factored or vertex form, but since there's that squared, that's going to make this vertex form. And so just by looking at it, I should be able to see the vertex. So I'm going to look for the opposite of h. Remember, h is in your house of parentheses, and you always want to do the opposite of that. And then you want to take k, and k is that number that's added or subtracted at the end, and make it negative 3. And then that's it. That's the only thing I'm looking for. I don't want to do any heavy math, I guess, to find anything else. The idea is you can look at the equation and get one quick thing. So if you look at number 3 looks a lot like number 2 because I see the parentheses squared. So that's going to put it into vertex form. And now I want to go for my vertex. And again, I'm going to look for opposite of h in my house. My house are these parentheses. So when I see 6, I want negative 6. But what I'm noticing is where in problem 2, they were subtracting 3. In this example 3, they aren't adding or subtracting anything. So what I'm going to do is add an amount. And the one number I can add that doesn't change the original problem is 0. And that will be my k value. All right, it's not 1 because adding 1 makes something bigger. All right, a few more. Number 4, I don't see any parentheses, so that is standard form. And I should be able to look at this and just see what the y-intercept is. So just by looking at it, all y-intercepts have an x value of 0, and it's just this constant, this one term that does not have the x with it. So why does that work? Because if x is 0 and I put it into my problem, 0 is such a great number to work with. So I have a bunch of numbers here. I'm going to be following the order of operations. So the first thing I do is when I have a bunch of numbers, parentheses, please excuse my dear Aunt Sally. I don't see parentheses. After that is E for exponents, and 0 squared is just 0. After exponents, I multiply and divide. So I've got some multiplying here and multiplying here. And that gives me 0 and another 0, and there's the plus 1. And when I have 0, take away 0 like this, I'm still at 0. Take that 0 and add 1, and I get 1. So if I go through and put 0 in and do all the math, basically everything disappears, and I get 1 left over. All right, number 5, I see parentheses. They're not a parentheses squared, so this is factored form. And again, this one's a little different. If you notice, this x plus 2 matches what happened in problem number 1 up here. So I can just take that factor. I can set it equal to 0, subtract 2. I get -2, and I'm going to write it as an x-intercept, so -2, 0. But the other one is not going to be as easy. So some people might starting to notice, well, hey, can I just take the opposite of this number? So I see a -3 and it's 3. And I look here and I see a 1 and it's -1. And if I look here, I could just take the opposite of that number and it's -2. So whether I set it equal to 0 or I kind of do this quick trick of just looking at what's the opposite, I can see my x-intercept. But the second problem is different because there is a 2 with that x. So that's why it's really important to not always look for shortcuts. Here I would add 3. And then I would divide by 2, and I would get 3/2. And I'm just going to leave my answer as a fraction, 3/2 and 0 as my x-intercept. Again, all x-intercepts have the y-coordinate being 0. So number 6, I've got parentheses, and I would say it looks more like, let me switch here, hold on, sorry. It looks more like factored form because I don't see the parentheses squared. But it doesn't quite look like number 5. But if you really want to make it look like number 5, you could do this. You could just say y equals and do x plus 0 because that still is worth this x and then x minus 3. But it's not necessary to have this x plus 0. So I still take each factor, set it equal to 0. I'll go ahead and just finish this one. I'm going to add 3. So I get 3, and I'll write my answer as an x-intercept because an x-intercept is a point, so 3, 0. And on the other one, you know, right here, that is my answer. I don't have to do any math, so I'll write that. So those are my 2 answers, the ones in parentheses. All right, let's go through these pretty fast. So number 7, this is standard form. No parentheses. Again, in standard form, I can see the y-intercept. It's 0, and then the term that does not have an x with it. And again, standard form, just pointing out up here, is all addition signs. So when you look at number 7, you should really see this as plus -2. So you get -2. Number 8, that is also in standard form, but standard form would be plus -5. So I get 0, -5. Again, no math. I can just write these points down fast. And number 9, finally, last one, this is factored form. Again, just set each factor, the one that you can solve for. So there's actually 3 factors here, but this -5 is always going to be -5. So that has nothing to do with the x-intercept. You're just going to take the factors that have the x in it. So I'm going to add 2, and then I get 2, 0. And the other one, I'm going to add 3, and I get 3, 0. So again, just kind of looking back, you got to know your different parts, okay? You got to know how to label them. So we've got the axis of symmetry, we've got the vertex, we've got our x-intercept, our y-intercept, our maximum or our minimum, and then being able to recognize the 3 forms and which particular point that form can show you. And that's it.